All right, we're ready to move on to Chapter 8. So we've got some vocab for you, of course. So first we have a ratio. Now you guys have heard of ratio before, but let's go over it again. A ratio is the quotient of two numbers. And quotient, that's a vocab word from algebra and pre-algebra. That represents division. So there are some different ways to represent ratios. Here's an example. The ratio of 2 inches to 7 inches can be written 2 divided by 7, 2 over 7. You could write it as 2 and then a division sign, 7. Sometimes you'll hear it as 2 to 7 or 2 and then a colon. And that one we read as 2 to 7 also. So of the four options, the fraction and the colon, those are the best ones that we're going to use. All right, this is important. Ratios are always reduced to lowest terms. So we're going to make sure that all of our fractions are reduced. All right, and then just a quick example. The slope of a line, you guys know about slopes of line, is the ratio of rise to run. So it's comparing the rise to the run, and you guys have done a lot of that in algebra. So we would say that slope is equal to rise over run. There we are representing it as a fraction. And then let's say here's our slope, our rise, and our run. Let's say we went up 3 over 2. The rise would be 3, the run would be 2. And there's the ratio, which represents our slope. All right, now that we know about ratios, let's talk about a proportion. Proportion is an equation, so it's going to have an equal sign in the middle, stating two or more ratios are equal. So some examples, let's say we have 1/2 is equal to 5/10. So this ratio is equal to this ratio. That's an equation stating two ratios are equal. You also could write it as, let's see, 5 to 15 is equal to 15 to 45. Or you also could see 4 over 6 is equal to 10 over 15 is equal to x over y. So that's what our proportions look like. However, most proportions are written this way, with A over B equals C over D. So A is our first term, and we're going to refer to that as an extreme. And we'll talk about that in the next slide, I think. B is our second term, and that one is a mean. C is the third term. That one is a mean. And D is the fourth term. And that one is an extreme. So if you look at this setup right here, A over B equals C over D. When we use the extremes and the means, we're saying that A is an extreme. So extreme over mean is equal to mean over extreme. All right, so now that we know what the means and extremes are in a proportion, it takes us to this means extremes product theorem. So in a proportion, the product, and remember product means to multiply, of the means is equal to the product of the extremes. So for example, let's say you have A over B equals C over D. The extremes are A and D, and the means are B and C. So it's saying that you can multiply the extremes, and you get AD, and it's going to be equal to multiplying the means, which is BC. It's actually just using your cross-multiplying and knowing that B times C is equal to A times D, but we get this fancy title, Means Extremes Product Theorem. So our means extremes ratio theorem tells us that either pair of numbers can be the means, and the other pair would be the extremes of the proportion. So if we're given that PQ is equal to RS, we can create some different proportions from that. We can say that R over P is equal to Q over S, or we could say P over R is equal to S over Q, or we could say that Q over S is equal to R over P. And those would all be correct and give us the same answers. A mean proportion is when the means are the same. So for example, you could have 1/4 is equal to 4 over 16. See how the means are the same? They're both a 4. Or maybe you could say A over X is equal to X over R, and here are the means right there, the same.